Hello students, how are you all? I hope everyone fine. In last class we complete sets, relation, function, maybe remember. So I'm moving to the next concept, the next chapter in the first PUC in order, textbook order is complex number. See, I told in the last class, okay, that I'm going to give you a new system of numbers other than the natural number, integers, rational number, irrational number, as well as real number. You're going to learn one more new system is known as complex number. So listen carefully. I'll start with one small, very simple introduction. See, suppose if I ask with you to solve this equation, x square minus 1 is equal to 0. How you will solve this equation? X square minus 1 equal to 0. How solve martiri? Maybe like this, right? X is equal to plus or minus 1. Then you write plus 1 and minus 1 are roots. Alva? You are going to write like this. Plus 1 and minus 1 are roots of x square minus 1 equal to 0, right? I hope you know about it. Solving quadratic equation, root, solution, everything, right? And these roots are belongs to real. So this is also known as are real roots. Real roots under the given answer. The answers are real numbers. So if I ask you with you to solve this quadratic equation x square minus 1 equal to 0, you will write the solution like this. Correct? Now, okay, if I ask one more equation to solve x square plus 1 equal to 0, almost same, no? Minus is plus hakirin. There is no difference and question is same, method is same. So what you will do here? Okay, if you try to solve this problem like this, x square is equal to minus 1, x is equal to plus or minus square root of minus 1. Now if you try to find out square root of minus 1 using calculator, I hope you know what calculator will give, right? What calculator will show? Error. There is no answers for square root of minus 1 using calculator, because calculator is only for the real numbers. Okay, other than real number, calculator will not understand. So definitely calculator will show answer error. Correct? So what you are going to write in real number system? You are going to write, okay, the solution does not exist. Alva? Solution does not exist. Definitely your answer must be like this. Solution does not exist. Where? In real number system. In real number system. In real number system, you maximum you can say that solution does not exist. Did you agree with me what I am telling? So I hope you understood what is the difference between these two equations. Here solution exists, plus 1 and minus 1. For this equation no solution, because you will get root of minus 1. This does not belongs to R. Since this does not belongs to R, so solution does not exist. But how many such equations are there? There are infinitely many equations where solution does not exist. So we can't leave as it. Suppose this is only one equation where solution does not exist. Okay, not an issue. We won't think about other than the real number system. But we have infinitely many equations of this kind where you are going to write solution does not exist. But that is not allowed. So one problem is now the next we are not thinking about the next part of this. But since this is not only one problem, there are infinitely many problems where the solution does not exist. So definitely you can't leave as it is when there are infinitely many equations where solution does not exist. So what we should do? We have to think beyond the real number system. We have to, the mathematician thought there may be some system which is other than the real number system. So when they started to think about other than real number system, definitely they are going to understand first what I mean by root of minus 1, and they understood also what I mean by root of minus 1. After understanding what I mean by root of minus 1, they started to define the new system known as complex number system. So now I will show you how complex number is developed in mathematics and definition, properties, problems. So because of this type of equation, I told there are infinitely many equations. See, all these have the same problem. Even this equation has the same problem. There are infinitely many quadratic equations where you will get root other than the real number. So when there are infinitely many, definitely there may be some system which is other than the real number system. So we have to understand now what it is. And after defining what is a complex number, you can understand what I mean by complex number system. Concept now I will show you how to solve this quadratic equation other than the real number system. Okay, now see here, I'll take that equation again. X square plus 1 is equal to 0. I'll solve just like the previous work. X square minus 1 is equal to 0. This implies I can write plus or minus square root of minus 1. right? Now I'm going to denote root of minus 1 as I. It is imaginary, this number does not exist, okay? In real number system this is not exist, but we have to go beyond the real number system, so we have to denote this something, okay, either you can think as imaginary, it is actually iota, okay? This number is called as iota by some mathematician, so or you can understand the first letter of imaginary, so I is used, otherwise any other English alphabet can be used. So let root of minus 1 is equal to I, then this implies x is equal to plus or minus I, root of minus 1 is equal to I, so x is equal to plus or minus I, so plus, therefore we can write now I and minus I are the complex roots, of x square plus 1 is equal to 0. Now because of this number I, root of minus 1, now you are able to solve, give equation of this kind, x square plus 1, x square plus 2, x square plus 3, anything, or x plus 1, anything you can solve. Let me take one more example. Suppose you want to solve x square plus 2 is equal to 0. Suppose you want to solve x square plus 2 is equal to 0. How you will try this? X square is equal to minus 2, x square is equal to plus or minus root of minus 2. See, you are not going to denote again root of minus 2 is equal to something. I fix, I and root of minus 1, root of minus 2 again it is not I. But how to manage this? Observe carefully, this I can write minus 1 into 2 alpha. So this is plus or minus root of minus 1 into root 2, correct? That is x square is equal to plus or minus, what is root of minus 1? I. Therefore, the roots of, okay, equation, therefore roots of this equation are, you know, I root 2 and minus I root, and these are all the complex roots, these are called complex roots. So like this, complex numbers started to introduce to mathematics, okay? So remember here a main important idea, I is nothing but root of minus 1. No need to write this in notebook, just I am giving introduction to complex number. Idana notebook al baribekantilla, but try to understand why complex number is there in your syllabus, or why it is introduced to maths, why real number system is not enough. Artha aita? Why real number system is not enough? When real number system, this equation does not have solution. Suppose there is a problem irlilla, but there are infinitely many such equations where you are going to write solutions does not exist in real number system, but such things are not allowed. When there are so many problems, definitely you are going to search solution for that, and the mathematician have got some solution for such equations by introducing the new number, okay, which is imaginary I, which is equal to root minus 1, and it is also actually known as iota, the first letter I, so it is used I. Or you can understand like I is the first letter of imaginary, so imaginary number does not exist in real number system, okay? So using this number you can solve any quadratic equation, and also maybe you know this is known as irreducible quadratic equation. Then 10th standard called reducible and irreducible. Reducible and irreducible quadratic equation in difference. So reducible is like a factorization made some real roots you will get. But irreducible quadratic equation you cannot do the factorization, and definitely it will not give you real roots, it gives only imaginary roots. Okay, understood what I am telling? When factorization is not possible, such quadratic equations are known as irreducible, and solutions of the roots of such irreducible quadratic equation is always, you know, imaginary or the complex numbers. Roots are complex roots. Okay, so like this, okay, complex number started to, okay, enter the mathematics by using the number iota. Okay, now we will discuss more about I, that is iota, because that number is new for you, right? That number is new for you, so listen carefully. I will show you the different characteristics of I or iota. Okay, you start writing from this I in bracket, write iota. I am just giving introduction to this. Already understood what I mean by I. See, remember here, I is equal to root of minus 1. I is equal to root of minus 1. This I important. I is equal to root of minus 1. Okay, it is known as iota. So what is I square? Root of minus 1 into root of minus 1. Alba? I into I. So what is root of minus 1 into root of minus 1? Minus 1. So remember, I square is equal to minus 1. I square is equal to minus 1. Okay. Similarly, what is I cube? I cube in here I square into I power 1. I square minus 1. I power 1 I. So I cube is equal to minus I. I cube is equal to minus I. Please remember this also. Now if I continue like this, I power 4 ಏನಾಗುತ್ತೆ I square into I square ಅಂದರೆ -1 into -1. So it is equal to 1. So now remember that I power 4 is equal to 1. So these four numbers you must remember, okay, to understand complex numbers. So I is under root of -1, I square under -1, I cube is minus I power 4 is 1. And one more benefit of this number is you can find out I power anything using all this. Remember, you can find out I power anything using these numbers. For example, suppose you want to find out, okay, question is like this in an exam for 1 mark, find the value of I power 17. You want to find out the value of I power 17. Hege find out ಮಾಡ್ತೀರಿ? Right, take I power 17 and try to express this in terms of I power 4, because you know I power 4 is 1 alva. I power 4 17 gantu guarantee hogala. So at least you can come near to 17. Which number you can come near to 17? 16. So hege 16 padodu? How to get the 16? Raise the power to 4. So I power 4 to the power 4, and then okay, so this is only I power 16, 4 into 4, but we need I power 17. So in multiply I power 1. So this is I power 16 into I power 1. Okay, now this step is no need to show it. It is again I power 17. Just let it be as it is. We know that I power 4 and 1. So 1 power 4 into I. What is 1 power 4? 1 only. So what is the answer? I. Like this you can solve. You can find out the value of any power of 5. See, if I take one more example, I power 112. I power 112. Okay, this is just an example to show we can find out any power of I. So can you express 112 by 4? Okay, so to get this in number, you just start dividing by 4. 4 in divide ಮಾಡಿ ಏನಾಗುತ್ತೆ ನೋಡಿ 2 times 8 ಅಲ್ವಾ, remaining 3. So it is 4 8s are 32. It is exactly divides, right? So this you can write as I power 4 to the power 20. 4 into 8 32, 2 4 4 8 into 3 11. So it's perfect. So what is the answer? Answer is 1. That's it. See, very easily you can find out power of anything, power of I for anything using the values I cube, I square, I power 4 and so on. Artha aita? So this is about iota. You should know this concept exactly to understand what you mean by complex number. Idu artha aita alva? Sure? So remember, I is equal to root of -1, I square -1, I cube minus I power 4 is equal to 1. Okay, so I'll give you one information as a note. Please remember this. Okay, see, entrance exam point of view, this is an important one. Okay, note I power 4n is equal to 1, then okay, if I power 4n okay is equal to 1, then the least value of n is, can you tell me what is the least value of n for that I power 4n? For that I power 4n is equal to 1. See, which is the least power of I, where I power that power is equal to 1? I square, no, -1, I cube minus I power 4 is 1. So least value power of I where it is equal to 1 is 4. ಇಲ್ಲಿ ಏನಿದೆ 4n. So what is the least value of n? Least value of n is 1. So n should be is equal to 1. The least value of n which satisfies this expression is n is equal to 1. So this gives one more information. If power of I is a multiple of 4, if power of I is a multiple of 4, remember always it is equal to 1. If the power of pi is a multiple of 4, that expression is 100% equal to 1. Artha aita? So this is about the first very important concept of complex number is iota. Artha aita? Now I can define what you mean by complex number, basic operations on complex number, properties of complex numbers, and problems based on properties. So this is introduction part. In notes ಅಲ್ಲಿ ಬರಿಬೇಕಾದ್ರೆ ಇಲ್ಲಿಂದ ಸ್ಟಾರ್ಟ್ ಮಾಡಿ heading with iota, write all this information. Understood? So next concept, definition of complex number. So let's define, this is an important term. To understand exactly what you mean by complex number, you should understand what is the definition of it. Okay, now I'm going to define, listen carefully. A number of the form a plus ib, a number of the form a plus ib, where a comma b belongs to R and the real numbers, and I is equal to root of minus 1 is called a complex number, is called a complex number, a number of the form a plus ib, a number of the form a plus ib, where a and b are the real numbers and I is equal to root of minus 1 is known as complex number, is known as complex number. Okay, to understand this perfectly you must be able to give some examples. Okay, let me write some examples. Yeah, 2 plus 3i, 2 plus 3i, yeah, it is in the form of a plus ib, where a and b are real number, I is equal to minus 1, root of minus 1. Okay, like that 1 minus 3i, alva, this is also one example. 2, whether this number is a complex number or not. Can you tell me whether this is a complex number or not? Is this number in a plus ib form? Is this number in a plus ib form? Okay, maybe your first answer is, okay, if you are in my class, not virtually, okay, then definitely you will say, no, this is not a complex number. Why? You're going to tell that, or you're going to explain that 2 is not in the form of a plus ib. But this is also a complex number, because this 2 can be expressed as 2 plus I into 0. Is it true? Yeah, this is true, no? A plus ib. What is the condition? A and b belongs to R, and a 0 is also real number, so 0 is also possible, right? So 2 can be expressed as 2 plus I 0. Did you agree with me? So 2 is also complex number, right now, right? So remember, it's not just only about 2. Even if you take half, it is also a complex number, because this can be expressed as like this. Or you take 2i, only 2i, this is also a complex number, because this can be expressed as 0 plus I into 2 or 2 into I. So what is the conclusion you can write here? Every real number is a complex number. You take any real number, it can be expressed in terms of a plus ib. Here you can ask one doubt. So then why we should learn complex number again? We know okay, everything about it. How? See, I just told that every real number is a complex number, but every complex number is not real. So you're going to learn complex number because you will get some number which is other than real number. I know you learn up to real number system perfectly, but still you will get few numbers which is not than real number, and we have to learn about those numbers. But remember, every real number is a complex number, but every complex number is not real. See, these are all belongs to complex, I like it, this all belongs to complex number system. But out of this is not belongs to real number, this is not belongs to real number, this is belongs to real number, this is also belongs to real number, but this is not belongs to real number. But all these are complex number, no doubt in that. So every real number is a complex number, but not its converse. Please remember that. Okay. So now I am going to define what I mean by complex number system. Okay. Complex number and then a number of the form a plus ib, where a and b are belongs to R and I is equal to root of minus 1 is called complex number. Okay. I'll give you one information here. I'll give you this as a note. Okay. Note 1. If a plus ib, if it is a complex number, okay, then A is known as real part. A is known as real part, and B is known as imaginary part. Imaginary part of a plus ib. Please remember this important information, real part and imaginary part. Okay, remember the first part, which is free from I, okay, is known as real part. The real number which is along with the imaginary number I, it is known as imaginary part. And remember, a real part and imaginary part both are real. Imaginary part and the imagination are beyond, don't take beyond this level. Imaginary part is nothing but a real number only. See, for example, if I write here, for example, I'll write the example for real part and imaginary part here. For example, minus 2 plus 3i. Tell me what is the real part. We write a short r dot p, real part. In minus 2. Imaginary part, I dot p, 3. I 3 badre wrong aito. You are not writing 3I, just 3. The coefficient of I is known as imaginary part, and other term definitely known as real part. So remember, a plus ib is known as a complex number, where I is equal to root of minus 1. Both a and b are the real number. In that, a is known as real part, b is known as imaginary part. So theory artha aita? Please remember definition. You may get an exam, define a complex number. A number of the form a plus ib where a comma b belongs to r, and I is equal to root of minus 1 is known as complex number. Very good. Okay, so now I am going to define complex number system. Complex number system, like real number system, integer number system, natural number system, it's known as complex number system. Listen carefully. The set of all complex numbers, the set of all complex numbers, set of all complex number is known as complex number system. Complex number system. It is denoted by C, capital letter C. Okay, that is C is equal to set of all complex number. The complex number ಹೇಗಿರುತ್ತೆ a plus ib, such that where both a and b belongs to R and I is equal to root of minus 1. This is known as complex number system. Okay, as I told you know up to now real number. Now you started to learn the new one. And also I told every real number is a complex number, but not the converse. What is the converse? Every complex number is not real. So I'll give you one information. This you saw in a set theory already in subset. You will get the extension of that. Every natural number is a integer, alva? Every natural number is an integer, but every integer is not a natural number. Every natural integer is a rational number. But every rational number is not integer. Every rational number is a real number. But every real number is not, a rational number. Because in real number we have one more system called irrational number, alva? Every real number is a complex number, but every complex number is not real. So after this, which is the biggest known set for you now? Complex number system. Before complex number system, the biggest known set is a real number system. After introducing this concept, definitely the biggest known set up to now, we don't have the update in this, research is not done, other than this, like we don't have any other set or system which is bigger than complex number system up to now. You may get in the future, but up to now, the biggest known set will be the known system will be the complex number system. And the difficult section to understand, in this system is the complex number system compared to remaining all. So please remember this information. N is a subset of Z, Z is a subset of Q, Q is a subset of R, and R is a subset of C. So this is about complex number system. C, capital C or hige use martave. Don't worry, just let it be C only. But it should comes like this in our set builder form. A plus IB, where A, B belongs to R and I is equal to root of minus 1. I hope you understood what I mean by complex number system. Now you are ready to learn the basic operations on complex number system. We are going to solve, we are going to apply addition, subtraction, multiplication, division, and other than these we have a few more algebra of complex numbers. So we are going to learn now algebra of complex number system. Next heading, algebra of complex number, algebra of complex numbers, complex number system, algebra of complex numbers. As a first concept of algebra of complex number, we are going to learn equality. That is, we are going to understand how to equate two complex number. How to equate two complex number. Observe carefully. If a plus ib is equal to x plus iy, suppose two complex numbers are equal, then A is equal to x and B is equal to y. That is, two complex numbers are said to be equal only if, or if and only if, okay, their real parts are equal, and imaginary parts are equal, remember that. So two complex numbers are to be equal if their real parts, okay, real parts as well as imaginary parts are equal. So two complex number equal as I know, A is equal to x, B is equal to y. Please remember that. I'll give you an example for this. See, for example, if 2 minus 3i is equal to x plus iy, then can you tell me what is x and y? Here we are equating two complex number alva. According to the definition, what is the x? You have to equate x with the real part. Why? Because x is a real part in the unknown. So x is equal to 2, y is equal to, remember it is minus 3 because y is equal to minus 3. Remember that, okay? Y is equal to minus 3. Like this, you can use this algebra of complex number, that is equality or equating two complex number. So please remember, two complex numbers are equal only if their real parts are equal and imaginary parts are equal. Artha aita? So this is the first very important basic algebra of complex number, equality. Understood? So next algebra of complex number is addition. We are going to learn how to add two complex numbers. We already learned how to add two real numbers, alva. Integer, from maybe in first standard you started to learn how to add integers. Then, okay, maybe in third, fourth standard you will learn how to add rational numbers. After that, real numbers. Everything is done, right? So now we are going to learn how to add two complex numbers. Okay, listen here. See, usually we represent complex number as z. Z agbekante enilla rules enilla, but usually we take the complex number is denoted by z, small letter z or capital letter z, whatever, okay? So let it be z1. Let z1 is equal to x plus iy and z2 is equal to a plus ib, okay? B2 given complex number, B2 given complex numbers. So if these are the two given complex numbers, here I will define addition as well as subtraction. Both I will define together. Now, I have to separate agmadala. This heading will barbiduttene. Then first one, okay, z1 plus z2 is x plus iy plus a plus ib. Usually you hege add martiri ಎರಡು factor ಅನ್ನು ಹಾಗೆ start ಮಾಡಿ. But in addition, okay, or whenever you are adding, you add the real part plus I into imaginary part. This is the addition. This algebra says that whenever you are adding two complex number, you have to add the real part separately, add the imaginary part separately, then final answer must be in the form of a plus ib and the real part plus I into imaginary part. For example, okay, if z1 is equal to 1 plus I, z2 is equal to minus 3 plus 4i. Can you tell me this implies z1 plus z2 ಹೇಳ್ಬೋದಾ? ಏನು ಹೇಳಿದೆ? How to add two complex number, add the real part and add the imaginary part. Minus 3 plus 1 ಎಷ್ಟು? Minus 2 ಅಲ್ವಾ? Okay, directly you can write, not an issue, but you are in the beginning, so better to first write in this pattern real part, then plus I into imaginary part. So what is the answer? Minus 2 plus 5i. This is the addition. Adding real part and adding imaginary part and writing the final answer in the form of a plus ib. Got it? What I am telling? So answer is minus 2 plus 3i. So in the same way I can define the subtraction also. So next algebra of complex number is subtraction. Let z1 is equal to x plus iy, z2 is equal to a plus ib be two complex number. Then, okay, then z1 minus z2 is equal to similar to addition, x plus iy minus a plus ib. ಏನು ಮಾಡ್ತೇವೆ? If you want to subtract two complex number, subtract the real part plus only I into subtract the imaginary part. This is a procedure to subtract two complex number. ಹೇಗೆ subtract real part as well as subtract imaginary part. For example, if z1 is equal to minus 2 minus 3i, okay, and z2 is equal to half minus 4i, or okay, let it be plus 4i. Now can you tell me what is z1 minus z2? Rules ಏನು ಹೇಳುತ್ತೆ? Subtract the real part. It subtract ಅಂದ್ರೆ already minus ಇದೆ, one more minus ಅಂದ್ರೆ plus ಆಗುತ್ತೆ. Plus only I into subtract the imaginary part. ಇಲ್ಲಿ ಏನಿದೆ ಅದನ್ನೇ ಬರೆಯೋದು minus 4. ಇದನ್ನು ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದ್ರೆ ಆನ್ಸರ್ ಬರುತ್ತೆ. ಏನು minus half plus minus 2 plus half ಅಂದರೆ minus 3/2 minus 7i. So final answer is of this is minus 3/2 minus 7i. ಅರ್ಥ ಆಯ್ತಾ? addition, subtraction. So I hope you understood the three algebra of complex number: equality, addition and subtraction. Okay, simple idenu kashta ansala. Okay, so we have few more complex algebra of complex number that we will discuss in next class. Thank you.